Good afternoon and welcome to our Digital Discovery webinar this afternoon. My name is Matt Minner here with Tasha Miller from ARM, Advanced Robotics for Manufacturing. Welcome, Tasha.
Yeah, thanks, Matt. Thanks for having me.
Yeah, so we're excited to talk today. We are going to cover some robotics and automation projects and some background from Tasha around some initiatives that ARM has, and specifically what they've learned around how these types of projects can struggle in manufacturing and how to really focus in and make yours a success. So before we get into that, I'm just going to go over a couple quick overview slides on our Digital Bridge program that is making this webinar possible. So our Digital Bridge program is funded through the EDA and the 2023 Build Back Better funding award. And this is actually one that funded 5 projects, of which Digital Bridge is one, and ARM is the recipient of an additional project, which is the focus of what Tasha is going to talk about today around their Robotics Manufacturing Hub. And this is all geared to support regional manufacturers with technology adoption. In our Digital Bridge program, we do have a number of other partners that we work with as well on the extended team that are part of our program. That's the University of Pittsburgh, the Manufacturing Futures Institute through CMU, the Digital Foundry at New Kensington, Pittsburgh Technical Council, or the Tech Council, and JARI. And we do have a wide range of resources specifically around technical assistance, and it's particularly applicable today to talk about some of the robotics related projects that ARM and Catalyst have collaborated on, from the particular around a lot of the front end services and helping manufacturers explore, identify these opportunities, develop business cases, requirements gathering, and then run programs to be able to do some selection and implementation of projects. And in addition to those types of technical assistance resources, there is access to a range of R&D and demonstration facilities, access to capital, particularly if you are in Butler County, workforce development, and through PIT, a Pennsylvania Robotics and Technology Fellowship Program that allows manufacturers to engage with a graduate student team to work on a project. So it's really a great exposure for students to manufacturing and manufacturers to the future workforce. And while we're talking about robotics today, we are able to support a range of technologies through this program. So whether it may be robotics, or if you're looking at deploying additive manufacturing in your facility, or need cybersecurity support, or around digitization, data-related problems. And this is a recurring webinar, so stay tuned for our upcoming sessions. And with that, I would like to hand it back over to Tasha. And so I'll make you the presenter, Tasha. So you should be able to present now. No, you can go ahead and get started.
All right, am I coming through?
You are.
All right, thanks, Matt. So I'll just introduce myself. I'm Tasha Miller. I work at ARM Institute. It stands for Advanced Robotics and Manufacturing, and I'm a program manager for our Build Back Better initiative, which we call Robotics Manufacturing Hub. So just some background on ARM, if you're not familiar with ARM. We were established in 2017, initially out of funding from the Department of Defense, with a sole mission of reshoring manufacturing here in the US. We built a consortium of over 430 organizations. It includes startup companies, universities, robotic companies, and manufacturers. And we've invested approximately $160 million into projects to help bring about technology for robotics for manufacturing. So Matt kind of mentioned that we're a sister project to the Digital Bridge program. So we've got what we call the Robotics Manufacturing Hub, and we work very closely with Catalyst Connection in this program. The piece that we focus on is what we call de-risking. And so I have a fun little graphic up here. I think depending on who you ask, you can get a different answer for what exactly is de-risking. So I'll give you my version of it. As a manufacturer, you're probably in this position where you're the two birds on the perch, and you want to jump into a new venture. It's more than likely that you can jump into it and fly with success, but you want to do some analysis and proof of concept first, just to make sure that everything's going to go smoothly, because the risk could be very great to your business. So, you know, with the ARM Institute and our history, we've seen robotics be deployed onto manufacturing sites with great success and improve the competitiveness of various manufacturers and help them reshore some of their operations. And we've also seen some manufacturers struggle or not deploy it in the way they wanted to, or not get the results that they wanted to. And so that's what brought about this concept of de-risking. How do you take the risk out of that final deployment? And so I pulled up some case studies. These are ones that are just out on the internet. I didn't want to throw any of our partners under the bus with any of their failures that we've helped them through. So the first one is Craftsman. Around 2019, Craftsman wanted to bring some of their manufacturing back to the US from overseas, and they wanted to heavily rely on automation and robotics because the cost of labor in the US is more than it is overseas. So the idea was, hey, we can use robots and only have 500 employees down at this site in Texas. What ended up happening, they got launched, and then 4 years later, they ended up shutting down their automation factory. So what they were trying to build is their socket line here in the US. And so some of the statements that Craftsman made, we endeavored to make tools here in a new and innovative way. COVID and supply chain challenges, coupled with technology that did not meet our expectations, resulted in discontinuation of operations. And then their VP of Global Operations at the time also said they struggled from attrition of their deep knowledge and the people that understood how the tools were made. So kind of digging into this, what was the root cause? What caused this failure? Snap-on, a competitor to Craftsman, has done a great job of deploying automated factories here in the US. They're actually achieving an 8-to-1 ratio of people to robots. And so quotes from their CEO on how they've been so successful is, you know, they start by understanding how the product is made from the get-go. So what I want to highlight with this Craftsman case study is you can't really just replace people with robots. People have knowledge of the craft, they have knowledge of the industry. And so what caused Craftsman to not be successful in this is they didn't have the knowledge of the tool making and the tool design incorporated into how they were going to deploy automation. Another case study, Boeing, which Boeing successfully deploys robots and automation all the time. So this is just kind of one little failure, but they've had a lot of successes. They wanted to use robots to help manufacture their fuselages. So the goal is to have robots drill holes and add fasteners for the fuselage panels. The robots struggled to keep the hole drills aligned for the fuselage panels, which created a lot of rework for the people doing the job. They ended up abandoning the project and giving the job back to the machinists because using the robots in this way was more complicated than just doing it manually to begin with. And so when you when you dig down into it, they didn't really do a lot of proof of concept or check the reliability. So maybe they proved that the robot could do it once, twice, but they didn't really do any like 200, 300 plus scenarios to see if it could reliably and repeatably do it. So they didn't quite understand the limitations of the technology and how they were deploying it. And then the task complexity was much more complicated to tackle with automation versus just having people manually do it. And then the last case study I've got here is Adidas. They wanted to have a robotic shoe factory or an automated shoe factory that could just spit out shoes and spit out customized shoes. They invested in something what they called their speed factory, and so the speed factory had machines that could do automated molding of soles, cutting, sewing, automated knitting, and really instead of just focusing on one shoe line, they tried to bite off and do multiple shoe lines. So within 5 or 6 years, they ended up shutting down their speed factory. And so TechCrunch did some analysis of what caused it to shut down. And what it boiled down to is their staff and their process became too bogged down reconfiguring robots and their technology to cater to the multiple steps required in shoe manufacturing. So their production became very limited. So they didn't quite understand what their high volume parts are. They didn't identify high volume parts. They didn't understand how that would impact their business if they couldn't do multiple shoes. And so they really didn't have the technology and business case to match to make this successful. So that brings me to what ARM recommends when you take on automation projects, that you need to balance certain factors and look into certain factors to make sure that each point on the triangle is addressed. Right, we talked about craftsmen not really considering people and how that knowledge set should be incorporated and how they should have champions and that they should use the knowledge base that they have in the design of their automation. We looked at sewing, not fully understanding the limitations of the technology and not doing enough proof of concept and experimenting work before deploying their system. And then we looked at Adidas, who didn't fully look into the business case and understanding that the business case might not be there if you can't do multiple parts. So I put together some key points that ARM recommends looking at when you look at automating, and Catalyst can help with this as well. And so we'll go through these key points, and then we'll talk about the process that we also recommend to make sure that you cover all of these key points. So first step is understanding what technology is available. Get yourself out to trade shows, check in with organizations like Catalyst, check in with the ARM Institute. We've got an entire robotics lab here. Check in with different vendors, know what's out there, and then also understand what was the intended design of the technology, how is it being deployed today, and has it ever been deployed for the application that I have in mind? What were the results of that? What is the technology good at? So what are the strengths of the technology, but also understanding what are the limitations, what could go wrong, or what does it struggle with, or what do you need to design? Just got a reminder. But yeah, what are the limitations? How do I make sure that those limitations don't affect my automated process? And then this is one that's really important. It's really easy to say, oh yeah, I'm just doing machine tending. I just take this piece here and put it in the mold, press a button, the mold does its thing, and then I pull it back out and put it in this pile. But a lot of times there's a lot of small details in that process that you don't think about, or a person doesn't think about, such as like, I line them up this way. This is how I find center in the machine. This is how I clean off the piece before I put it into the machine. Every once in a while, the machine gets stuck or does something weird, and then I have to do this. So there's a lot of things that people do intuitively that a robot isn't necessarily going to do intuitively. So you really have to analyze your process down to every single minutia step. And then from the business standpoint, Bill Gates was quoted saying, robotics and automation will highlight efficiencies or highlight inefficiencies in a process. So if your process isn't healthy, say, you're not kind of following the steps of lean manufacturing, maybe you're moving materials more than they need to be moved, or maybe you have inventory and stock piled up, and you're not generating things just in time. Those are going to be challenges for robotics and automation, right? A robot typically in manufacturing doesn't have legs, so it's not going to be moving material from here to there when it's machine tending. So if you run out of space to put the parts, that could be something that slows down your automated process. Whereas if you're building stuff just in time, you wouldn't run into that challenge. And then another important factor too is, what is your business strategy for the next 3 to 5 years? Are you trying to improve quality? Are you trying to reduce costs? What goals do you have? Are you trying to deploy into new markets? And then what aspects of your manufacturing line, making sure you analyze, okay, which ones are going to be the most impactful to my business? And maybe I should focus on those first. You also don't want to just pick something easy to automate to start with, because it might not have a huge return for your business. And then it also might create challenges and issues elsewhere in your production line. So really look at the dependencies as well, upstream and downstream. Are you eliminating a bottleneck with automation, or are you just moving the bottleneck somewhere else to be a problem for a different aspect in your manufacturing? And on the last segment of the balanced de-risking triangle is people. And so the way ARM looks at automation and robotics, they're tools. They help augment people, but they shouldn't be looked at as a replacement for people. It's similar to, going from a hand saw to an electric saw. It's going to help you be more productive. It's going to help you it's going to ease the burden on people. Use automation to help cover what we call the 3 Ds, dirty, dull, and dangerous jobs. But if your goal going in is just to replace people with robots, that's going to be a challenge, because people bring a lot of skills and knowledge to the table. So there's opportunities to where maybe you can have a robot doing the mundane things, or you can have a robot working certain tasks and people checking in on it every so often. But scenarios like skilled trades such as welding, it's not a good idea to just take the welder completely out of the picture and rely solely on the robot. That person brings a lot of knowledge and skills to the table that the robot's not going to inherently have. And then as you're making decisions about automating different processes, involve the workforce in those decisions. They're key stakeholders. They're the ones that are going to make sure that it gets implemented correctly. Let them be champions and stakeholders, and not bring them into those decisions early. Don't just drop a robot on the floor and say, hey, this is your new tool and you're going to use it, without doing any of the upfront work. There's plenty of programs out there that help enable training. So you can send your workforce to robotic boot camps. You can send them to trade shows. You can bring them down to our lab here at ARM for some familiarization. Catalyst has a lot of resources too for workforce development and training. So making sure that your people have the skills and knowledge to utilize the tool as well. And then, like I said before, incorporating that craft knowledge is equally important to the robotics knowledge. So the road to success, to cover all of those different points and get answers to all of those different questions. Start with a strategy, not just a business strategy, but an automation strategy or robotics strategy as well. Understand what's going to have the most impact to your business and help you meet your business goals. And then prioritize. So, okay, let's focus on the things that are the most implementable and will have the most business impact, and then work your way down. Get familiar with automation that's out there. Currently, there's tons of trade shows every year. There's trade shows that locally come here through Pittsburgh. Matt's got an array of resources. ARM's got an array of resources to help you get familiar with the technology and understand the technology. And the market's always changing. So just because you bought a robot 5 years ago doesn't mean you shouldn't go out and check what's the latest and greatest out on the market and how's it working. Analyze your entire process. You could do value stream mapping or other lean principles. I know Matt's done that with a lot of different manufacturers, but understanding where automation is going to have the biggest impact to your process, and also making sure that depending on what you automate, it's not going to cause issues elsewhere in your line. ARM also has got some different software packages where we can do simulations. So we can create a model of your entire manufacturing line and then automate parts of it through the simulation software and see how that impacts upstream and downstream pull rates, cycle times, interactions, things like that. Get your workforce to buy in. If you're planning on getting a robotic welder, bring your welders into the picture, bring them down to our lab. We've got a robotic weld cell that we'd be happy to share, but try to incorporate the knowledge from your business and help upskill those people to take the business further. And then know the limits. What are the limits of the technology? What are the limits of your business? What are the limits of your people? Understanding all of that and analyzing all of that's going to go a long way. And then we definitely recommend doing proof of concept work, even if it's something that has been deployed in various other factories, but for slightly different parts. It's good to either through modeling and simulation or physically in person, make sure that the different aspects are going to work in the way that you expect them to work. Just because you see it work one time, you should run experiments, see if it can do it 100 times. How often does it fail? How often does it need intervention? There's various different things that we can do here in our lab. We can do end effector studies. We can do proof of concept of changing the process. We can see if it's within the limits of the robot itself. But test it out. And then know that when you're signing up to any type of automation or robotics project, you're basically signing yourself up to lifelong learning with that technology. It's just like buying any other technology, whether you get a CNC or a plasma cutter. When I hear the term turnkey robotic solution, it makes me nervous because it sets the expectation that you don't have to know anything about the system. You don't have to know how to troubleshoot. And yes, there are companies out there that offer services along with that, but being an informed buyer and at least knowing a little bit of how it's supposed to work and how to solve simple problems is going to go a long way. It'll keep you from shutting down and being offline and incapable of not being able to help yourself. And there's a lot of free and good resources out there to help you on that learning path. So if you can hit these green flags on your road to robotics and automation, it should be a good road to success. So here's a process that we work through with our manufacturers. Catalyst does a lot of this process as well. We don't necessarily care who does the steps of the process, but anytime we take on a de-risking project, we want to make sure all of these steps are addressed, because by going through these steps, you end up looking at the technology, the people, and the business case. So it always starts with a site visit. ARM can come out on the site visit, Catalyst can go out on the site visit. A lot of times we've gone together and collaborated on that initial consult. Coming out of the site visit and kind of seeing things in person and asking questions as an unbiased third party, we're able to determine what's a good fit for automation, what's possibly not a good fit for automation. There's resources and tools to help figure out the business case. What would your return on investment be? Does that return on investment make sense for you? What's your end goal? Are you trying to improve quality? Are you trying to cut costs? Are you trying to fill some function that people just can't stand doing, like standing there and grinding weld beads all day? We can pull that together and do an overall assessment. And then defining requirements. Not just defining requirements so that you can get quotes, but defining requirements so you know and understand them. It's almost doing some expectation management of what are the bare minimum things that I would need the automation system and the robot to do for this to be a worthwhile venture for me. And we're not just talking technical requirements of, oh, I need to move 100 parts per minute. We're also talking business requirements. So, you know, can I double my throughput for one person by augmenting them with automation? Or can I increase my margin per part by instead of having to do this with 2 people, I can do it with 1 person. But defining those requirements, not only so you can share them with others, but so that you understand them yourself. And then do a proof of concept. A lot of system integrators and robotics providers will do that proof of concept for you. And if they can and are willing to, I would definitely take them up on that offer. There's factory acceptance testing, site acceptance testing. Make sure you have those things built into your plan. If you don't have an integrator in mind, make sure you work with Catalyst or ARM. We can get you connected based on your requirements with providers that specialize in certain areas, and that would be the best fit to implement your project. And then, of course, there's implementation. Most projects aren't just install it and then it works the next day. There's usually a learning curve and a little bit of tweaking things to get it to the end state that you want it to be. And so that's where that learning piece comes in as well. And we can also connect you to the training and information that you would need so that you can get through that phase. Or Catalyst and ARM can also consult until it gets to the point where it's deployed in a way that you want it to be deployed. And so I want to give an example of a manufacturer that both Catalyst and ARM has worked with to go through this process. And so it's a company that does flame hardening of cast parts. They get a shipment of cast parts in, they flame harden them, and then they need to package them back up to go back to the casting company. So one of the challenges they had 37-pound parts that were sprayed with oil and then crated. As you can see in the picture, the parts don't really have good grip points and they get packaged kind of tightly together. They initially started working with Matt over at Catalyst, just looking at their entire operation, what would be a good fit from a business case perspective, from a workforce integration perspective, to automate. What resources did they already have on hand that could help help with that. So they had a robot in their facility that was underutilized. Okay, so what applications could we possibly use this existing robot for? So they did a lot of that upfront work with Matt. They identified, hey, let's do our pick and place of our parts and packaging with our existing robot. So then it was time to look into proof of concept and the technology. What was their robot capable of? How would you grab the parts? Can you reliably grab the parts? What does the kinetic loading look like on the robot arm? What is the process flow? What kind of environment are you asking the robot to operate into? So a lot of those technical risks, ARM was able to step in and either do engineering analysis, simulation, or even live proof of concept to address those risks and make sure that they weren't going to be issues when it came to deployment. So what exactly did we do? So the original process was taking this cast part via a magnet and a person, moving it. The person they would then grab an oil spray gun, spray it down, and then put it in the crate. One of the challenges for robot vision is oil aerosols. If you get that on the camera, then it's not going to identify the part correctly. So is there a way to redesign the process so that you're not spraying and maybe just dipping so that you don't have aerosol oils? So we were able to look into that and prove that a robot could do that. We also looked at various end effectors, making sure they could withstand the oil dip, making sure that the combination of the tool weight and the part weight wouldn't exceed the robot's limitations. How would they move together? Looking at all of that in modeling and simulation, partnering with a computer vision company and software company for the pick and place. So like what orientation would the parts need to be in for the software to correctly identify it? What pick locations were the best for the part so you could reliably pick it up? So where's the center of gravity? What happens if I don't grab it at the center of gravity? How does it fail? And then kind of combining all that information into not just a proof of concept here in our lab, but also doing a proof of concept out at the client site with their robot. So kind of walk you through what could go wrong in manufacturing when deploying robots, what aspects to look at, how ARM looks at it, the process that ARM takes to do that. And so I want to share a little bit more about our program and our lab and the resources that could be available to you through this Build Back Better grant. Here's a picture of our lab here at Mill 19. So we're co-located with Catalyst Connection. So if you're down visiting Catalyst Connection, feel free to come downstairs to the first floor. There's usually somebody always here in the lab. I'm in the lab here today. And so we'd be happy to show you around. We've got 12 robots at this point. So we've got collaborative robots, and we're brand agnostic. We don't stick with one brand. So we've got UR, Fanuc, and Yaskawa. Just got a couple Denso robots in as well. So you get to see a variety of different interfaces and technologies. We've got inspection equipment, various 2D, 3D vision sensors, scanning sensors. At the back end of our lab, we've got a material removal cell. So we've got a robot with an orbital grinding end effector. We've got robotic welding. And then we also have a robot that can handle up to 180 kilograms for material handling of large parts. An event that's coming up is on November 21st. We're doing a robotic welding workshop for manufacturers, co-hosting that with Matt and Catalyst. So want to make that invite open for you guys to come out. We'll have some speakers lined up. We're bringing in industry experts from our consortium that specialize in robotic welding. We'll be doing some live demos, throwing some sparks, and having a bunch of resources available if you want to get familiar and do that familiarization piece with robotic welding. And then if you want to work with us more, here's a QR code to get to our resources. You can always email rmhub@arminstitute.org, and we'd be happy to work with you and talk through these services. And always an open invite to come visit us in our lab. We want our lab to be a center for the community to explore robotics, test out robotics, and ultimately deploy robotics successfully. So with that, I guess open to questions, and I appreciate your time today, and thank you, Matt, for having me on to talk about de-risking.
Yeah, excellent. That was great information that you shared, Tasha. We really appreciate it. There's one question I think you answered through the rest of your talk into the Robotics Manufacturing Hub, but Ashish, if you had a further question, feel free to put that in the chat. But I wish you did talk around, being able to test technology before going into the manufacturing facility, and maybe extending that, Tasha, talk a little bit about how even with unique applications, while you have a lot of robotic cells that you're working to, leverage those existing systems, but even like, for example, that Penaflame example was you purchased some unique hardware that like the RMH is able to go out and get specialized hardware that, say, if a new application comes in and they can leverage one of your cells, but there's some specific hardware or something that's needed to do their de-risking, that's something that you're able to work with, right?
Yeah, definitely. We can purchase unique hardware. For the Penaflame example, we purchased something off the shelf, and then our team of engineers, I don't want to say re-engineered the whole thing, but they re-engineered certain aspects of it, and then we got it machined to make it a better fit for the application. So we can provide those engineering services as well, such as end-of-arm tooling design.
Yeah, so it is a really great resource for manufacturers looking to explore, and especially ones where it's just something that you'd like to get your arms around better. Maybe you're just not even sure if it's something you want to, a path you want to go down, but it's something that you've been thinking about. This is a great opportunity to leverage these resources. So, well, with that, Tasha, I think we are all set. So I'd like to thank everyone for joining in today. This will be recorded and posted up on the Catalyst Connection site, and ARM will also have the link there, so we'll be able to rewatch and also share with other folks. So thank you again for joining us, Tasha.
Yep, thank you, and feel free to reach out.
Have a great afternoon, everyone.